Significant figures are a measure of how precise a value is, or how reproducible a measured value is. And the more significant figures you have, the more precise the measurement, while the fewer sig figs you have, the less precise. So what we can do is we can consider an example of a temperature measurement. You use your thermometer and you find a temperature of 25 degrees Celsius, and this value has 2 sig figs, and the first value, the 2, lets us know that our measured temperature is pretty definitely in the 20s. And our second value, the last sig fig, is always where the uncertainty in the measurement lies. So this value indicates that we have a measured value in the mid-20s, but we're not 100% sure that it's 25 Celsius. It could be anywhere between 24 or 26, but we're pretty confident that it's in the middle of the 20s. And using sig figs is important because it gives us some indication of how reliable our measured data are. And of course, there are a number of rules for deciding how many significant figures any measured value has. So we'll split the rules up into 2 categories, significant and non-significant. So the first rule is that non-zeros are always significant. The second is that zeros between non-zeros are also significant. The third is that zeros at the beginning are non-significant. They just indicate the position of the decimal point, basically. It gives you an idea of the scale that the number's on. The fourth rule is that zeros are significant to the trailing zeros. Trailing zeros are significant after a decimal place. And the fifth rule is sort of separate from these categories. Exact numbers can be treated as if they have infinite significant figures. So we can use these rules with a couple of examples just to give you an idea of how to apply them. Consider the number 1379.2. This has only non-zero values. All of them are therefore significant, so it has 5 sig figs. The number 23.05 has 3 non-zero values. One of them is a 0, and that 0 is between the other 3 non-zero values. It has 4 sig figs. If you consider 0.075, this value has 2 non-zeros, and it has 2 zeros. The zeros are to the left of the non-zeros, so that means they're just placeholder values. They would follow rule number 3. Zeros at the start of numbers are not significant. So this one only has 2 sig figs. 0.0750, however, has 3 sig figs. We can ignore the first ones, but trailing zeros after the decimal are significant. The number 2300 is probably the trickiest one. It's a little ambiguous. It has trailing zeros but they are to the left of the decimal place. This is 2,300. So really, this technically only has 2 sig figs. A much better way to write this would be 2.3 times 10 to the 10, or 10 to the 3 rather. Putting it in scientific notation makes it a lot more clear that there are only 2 significant figures. Some places, some high schools, will have taught you that you could also write this as 2,300 with a little decimal place in order to indicate 4 sig figs. That is okay, but it would be much more clear to write 2.300 times 10 to the 3 if you wanted to indicate that something had 4 significant figures. I'll accept the decimal place version, but I would prefer significant figures be expressed in scientific notation when it's ambiguous.